We're often asked to find the vertex of a parabola. That's the graph of a quadratic equation. And sometimes we're asked to use a specific process of completing the square to find the vertex. In addition to sometimes being asked to use the completing the square process, sometimes finding the vertex is simply going to be the easiest way to find the vertex will be completing the square. So it is important that you know how to complete the square to find a vertex. Here's an example. If we have the opposite of x squared plus 6x plus 14 is our function, and we want to complete the square to find the vertex. And I know you might be saying, well, but can't I just use the formula x equals the opposite of b over 2a? And yes, in this case, it might be easier to find the vertex using the opposite of b over 2a if you're familiar with that formula. But what if you're in a situation where you've forgotten the formula? Or what if you're in a situation where the problem has specified that you need to use a completing the square? So let's just practice this process so that when you encounter it, you feel really comfortable with it. Now to start with, I'm going to group the x's together. So that's going to be the opposite of x squared plus 6x. And I'm going to leave that constant, the 14, outside of that grouping. When there's a negative in front of the x squared, I know that it's a parabola that's opening downward because a negative parabola frowns, right? If you picture the parabola, sorry, that's not a very good drawing, but if you could picture the parabola as a face, it's frowning. You'd frown also if you had eyes that looked that terrible. But it's frowning when it's got a negative a, when the coefficient of x squared is negative, or when the lead term is negative, right? So we know it's a downward opening parabola. And to start with, for completing the square, we've got to factor out that negative. Here's what that would look like. We'd have f of x is equal to the opposite of and what we have inside the parentheses is the opposite of x, the opposite of negative x squared is x squared, right? And then the opposite of 6x is negative 6x. Notice that all I've done is I've factored out a negative. If we go back to multiply it, we'd have the opposite of x squared, which is what we started with, the opposite of negative 6x, which is positive 6x. Don't forget that 14, and that 14 was outside the parentheses, so it's not affected by this negative. Next, for completing the square, we're going to take that b term, the coefficient of x, the negative 6, and to complete the square, what we do with that is we take that negative 6, cut it in half, and square it. When I cut the negative 6 in half, I get a negative 3, and when I square a negative 3 times negative 3, I get a positive 9. So I have just added a 9 inside these parentheses, but really it's the opposite of 9. So I've inserted a negative 9. To counter that, I've got to add a positive 9 on the outside. Don't be thrown off by this. It's not plus 9 plus 9. It's the opposite of 9 plus 9, which by the identity property for addition eliminates that, right? The opposite of 9 plus 9 eliminate each other, cancel each other out to give us a 0. So really I've not changed the value of that function. Next, to complete the square, don't forget that negative is here. I'm going to factor the opposite of, I'm going to factor this opposite, so it's the x squared minus 6x plus 9, but this is really easy to factor because I'm just going to go back to this value, this negative 3 that I got when I cut the negative 6 in half, And what it'll be is x minus 3 in those parentheses. You could factor it to prove that to yourself, or prove it to yourself by doing x minus 3 times x minus 3. Do the FOIL of that, and you'll see that you're going to get x squared minus 3x plus 9. The minus 3x combines to a negative 6x. And then we've got this plus 14 plus 9. So we've got plus 23. And that's it. Our vertex is going to be x equals positive 3, because it's the opposite of this value. So positive 3, y equals 23. That's going to go off the chart here. So if you could ignore the increments here on the chart. So I'm going to re-index my graph. Let's say that this is x equals 3, this is y equals 23. So our vertex of x equals 3, y equals 23 would be right here. And if I found one other point, so for example, if I found what happened when x equaled 0, I could graph this parabola. But I know that it's going to be a parabola opening downward. It might look something like this. But that's how you use completing the square to find the vertex of a parabola.